Hi, today we're going to talk about hypothesis testing. First, hypothesis testing is when you make a hypothesis, which is an educated guess about the outcome of an event and test if the results of the survey or experiment have meaningful results. First, we need to study samples and use the results to generalize the results in the population. In hypothesis testing, we always have the null hypothesis and alternative hypothesis, which is HO and HA. When we conduct hypothesis tests, we decide if we should reject the null hypothesis, which means that we have enough evidence to support the alternative hypothesis. And if we don't reject the null hypothesis, that means that we don't have many evidence to support the alternative. Pretty easy. Also, to determine if we should reject the hypothesis, we select a significance level that is called alpha. The most common number used in alpha is 0.05. Alpha specifies the size of the rejection region, where the null hypothesis region is rejected. We always reject the null hypothesis if it includes the tails of the graph. Also, the correct way to make the hypothesis is by saying, if I do this, so the independent variable, then this will happen, which means the dependent variable.
Steps in hypothesis testing. First, arrange the data. Second, state the hypothesis. 3. Identify the test statistic and its probability distribution. 4. Specify the significance level. 5. State the decision rule. 6. Collect the data and perform the calculations. 7. Make the statistical decision. 8. Make the economic or investment decision. It is important to note that you need to set up the null hypothesis. This one will be the one the analyst believes will be true. The outcome of the experiment will say if it is true or false.
A principal at a certain school claims that the students in his high school are above average intelligence. A random sample of 13 students' IQ scores have a mean score of 112. Is there sufficient evidence to support the principal's claim? The mean population IQ is 100 with a standard deviation of 15. The step 1 is to state a null hypothesis. The accepted fact is that the population mean is 100. So, H0 means that the mean is equal to 100. The step 2 is to state the alternate hypothesis. The claim is that the students have above average IQ scores. So, H1 means that the mean is greater than 100. The fact that we're looking for scores greater than a certain point means that this is one of the tail tests. Step 3. Draw a picture to help you visualize the problem. Step 4. State the alpha level. If you aren't given an alpha level, use 5% or 0.05. The step 5 is to find the rejection region area given by your alpha level above from the Z table. An area of 0.05 is equal to a Z score of 1.645. The step 6 is to find the test statistics using the formula of Z. For this set of data, Z equals 112.5 minus 100, that is divided by 15 over the square root of 30. That equals 4.56. And finally, if step 6 is greater than step 5, reject the null hypothesis. If it is less than step 5, you cannot reject the null hypothesis. In this case, it is greater, as 4.56 is greater than 1.645. So you can reject the null.
Okay, so I'm gonna explain the second example, which is a machine fills milk containers with 1 liter each. However, it has not been filling them with that amount. There's a sample of 100 containers with a mean of 0.94 liters and a standard deviation of 0.3 liters. Using a confidence interval of 95%, should the machine be checked? So the first thing that we need to do is, first arrange all of our data, and we're going to state the null hypothesis. This is going to be the accepted fact, and this one is that the machine works if the mean of the population is the same as the mean of the sample. So we're going to write that down as HO, 2 points, mean of the sample equals to mean of the of the population. The step 2 is to state the alternate hypothesis, which is the claim is that if the means are not equal, then the machine needs to be checked. So we will write it down as HI, 2 points, equal, mean different than mean of the population. So the fact that we are looking for scores different than a certain value means that this graph has 2 tails. Okay, so it's not like a value is bigger than other. We're looking for a value different, so that means that it will have 2 tails. So the step 3 is to draw a picture to help you visualize a problem. The step 4 is to state the alpha level, which will be 5% because the confidence interval is 95%. So we're going to do 1 minus 0.95, which is equal to 0.05, which is 5% of the alpha level. The 5th step is to find the rejection area given by your alpha level above from the Z table. An area of 0.05 is equal to a Z score of 1.96. That's done by using a formula that will be written on the screen, and the value, the answer to this is a Z score of 1.96, and since it is bilateral, it will be minus 1.962. So then we will find the test statistics using the formula for the set of data, which will be written in the screen, and the answer to that is minus 2. So once we have both of those, of those values, we know that we need to find that value of minus 2 inside the 2 extremes of minus 1.96 and 1.96. But it is not inside of those 2 parameters. It is not in the HO. So because minus 2 is lower than minus 1.96, so that means that it is outside of it. So that means that we will reject the null hypothesis. So in other words, this means that the machine is not working right and it needs to be checked.